In this slide, we'll introduce the term eigenspace. Eigenspace is associated with the eigenvectors. In our previous equation, to find the eigenvector x, we arrived at this equation. We found that A minus lambda I must be have dependent column. It must be a singular matrix such that A minus lambda I multiplied by x equals to 0 when lambda is an eigenvalue. Now, we also show that x, when we solve for it, is actually has a general solution. It implies that it is not a single point in this example in the R2 space. It is a line along the R2 space. So in this example, 7 is an eigenvalue. 1, 1, the vector along this line, is an eigenvector. And here we want to be more specific. We say that all solutions 1, 1, 2, 2, in this example 3, 3, along this line are solution. And therefore this is a set of points along this line. And it is actually a subspace of Rn, because it also consists of the 0 vector and the subspace of the eigenvectors. All the eigenvectors corresponding to this lambda forms a space, and we call it the eigenspace of the matrix. So concretely, what does that mean? We still look at this example, and we know that there is lambda equals to, these two lambda are eigenvalues. Let's be concrete about it. Typically, we'll call one of them lambda 1 and the other one lambda 2, and we have v1 and v2 for the corresponding eigenvectors. Now, when we draw it, this diagram shows the eigenspace for the matrix A equals to 1, 5, 6, 2 as in example 2, and we found lambda equals to 7 is an eigenvalue, lambda equals to -4 as the other eigenvalue, and we found two lines, each line corresponding to the eigenvector, and these two blue lines is called the eigenspace of A. But in addition to saying the eigenspace of A, we are actually very specific. We want to say the eigenspace corresponding to which lambda. So this line corresponds to lambda eigenvalue equals to 7. The other line corresponds, the green line corresponds to lambda equals to -4. So to repeat, eigenvector is not a single point. It can be a line, like in this example, and later on we'll show you that it can even be a plane. Okay, and therefore we call it an eigenspace to allude it to that it is a subspace of, in this example, R2.